Water quality is an essential aspect of our daily lives, and understanding the factors that affect it is crucial for ensuring a safe and healthy water supply. In this tutorial, we will use Python to analyze a dataset containing water quality measurements and explore the relationships between different factors and water potability. We will use the PyCaret library for streamlined machine learning tasks and Plotly for data visualization. Now, before we dive into the code, let's make sure we have all the necessary packages installed. So first of all, we will install the PyCaret library by using this command, pip install -q PyCaret. The purpose of using -q while installing a particular library is that it suppresses the installation output and reduces the amount of information displayed on the console. PyCaret library aims to provide an end-to-end machine learning solution by streamlining the workflow from data preprocessing to model training and evaluation. It automates many tedious tasks, reduces code complexity, and allows for quick experimentation and comparison of multiple models. The PyCaret library is installed now. Next, we will begin by loading the dataset into a Pandas data frame. The dataset we will be using contains various water quality measurements such as pH, hardness, solids, chloramines, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, and potability of water samples. The dataset is loaded from a CSV file hosted on a GitHub using pd.read CSV. Next, let's check for missing values in the dataset and drop any rows containing null values. To gain insights into the factors affecting water quality, we will create histograms to visualize the distributions of various variables based on water potability. We will use the Plotly Express library for interactive and visually appealing plots. Now for data visualization, we will import plotly.express as px. Here we have taken pH on x-axis. The title we have given for our histogram is Factors Affecting Water Quality, as this is the histogram between pH and potability, so we have written pH in the title. The orange area in the histogram shows that the potability has the value 1, and in the blue area shows that potability has the value 0, as potability has two labels in the data set. If we move through this orange area, we can see that pH value shows the variation, and if we point at this particular point, the pH has the value 6.7 to 6.9 and the potability is 1. The count here shows 58. Now, what does the count value here shows is that it calculates the number of data points from the input data. It is obtained through the process of creating the histogram itself. When you call px.histogram function from Plotly Express, it automatically calculates the count of data points falling within each bin. This is the histogram between hardness with respect to potability, giving the title of Factors Affecting Water Quality and Hardness. Similarly, all these histograms are created to visualize the distributions of various variables based on water potability. To further explore the relationships between variables, we will calculate the correlation matrix of the dataset and focus on the correlation values with respect to potability. And here we have applied the sort values function, which will sort the values in descending order, giving ascending equal to false. In the output, we can see that solids has the highest positive correlation and organic carbon has the highest negative correlation with potability. Next, we will build our classification model. Let's utilize the PyCaret library to create a machine learning classification model. We will predict water potability based on the available features in the dataset. The setup function from PyCaret initializes the machine learning environment and prepares the dataset for model training. It is basically used to set up the dataset for modeling. The target variable is specified as portability, and a session ID of 786 is provided for reproducibility. The compare models function is called to compare the performance of various machine learning models on the dataset. This function automatically trains and evaluates multiple models, providing a comparison of their performance metrics. In the output, we can see that we have accuracy, recall, precision, and effort score of multiple models. Now for evaluating the model, let's choose the random forest classifier and evaluate its performance using the entire dataset. In the create model function, we have mentioned RF, which shows the random forest classifier that we will be using for evaluating our model. Next, predict model function is used to generate predictions on the dataset. Using the trained model, the predictions are stored in the predict variable. Finally, the head method is used to display the first few rows of the predicted dataset. The resulting data frame predict will show the predicted portability values along with the original features. So this was all about the code. We explored the factors affecting water quality. By analyzing a dataset of water quality measurements, we visualized the distributions of various variables and identified their correlations with portability. Furthermore, we built a classification model using PyCaret to predict water portability based on the available features. By examining the predictions, we can gain insights into the model's performance and its ability to classify water samples correctly. Python, with its rich ecosystem of libraries, provides powerful tools for data analysis and machine learning tasks. By leveraging these tools, we can make informed decisions regarding water quality and contribute to the development of effective water management strategies. I hope you have understand the code very well. Feel free to ask questions regarding the code in the comment section below. Happy learning. See you in the next video.